Since I know everyone here is actually ready to go, so let's go with class.
Yes.
Thank you, Angel. Okay. You're so very excited right there. Appreciate it. All right, constant multiple rules. So a constant k is going to be the coefficient, the number in front of the variable. That's basically it. It's multiplying that times whatever it is I have. So if I do, you need 5, 3, right, Victor?
Yes.
Oh, I just put them away. Yeah, 2, 3. Why did I say 5, 3? All right. So with the rule, I take my exponent, and where does it go? It goes out front, right? But there's already a 5 there. So what should I do with it?
Multiply.
Multiply. 3 times 5 is? 15. Now, what do I do with my variable? What do I do with that exponent?
Subtract 1.
Subtract 1. So it's going to be x squared. Just like Joseph was trying to tell me before, every time when I do the derivative, it should be 1 degree less.
I did.
You did? Someone did. Someone did, yeah. She's not here. She don't get credit. She can't. She's not here.
I'll take the credit.
Okay, you get the credit now. Okay, for all those people watching online. All right, same thing goes for the next one. So, for this next one, my derivative for g, actually, let me write out the whole thing. F prime of x. All right, so what do I do with that 2? Goes out front, but there's already a 1/2 out there. 2 times 1/2 is?
I think 2 times
Negative 1/2, yeah. Negative 1. Okay, negative 1.
So just be negative u.
To the first power, right? So, do I need to write the 1? No, I don't. It's implied that it is to the first power. If there is a variable there, it is implied that it is to the first power. Now, is pi a number? Or is it a variable? Is it a number or a variable?
Depends. I mean, it's a
It doesn't depend.
It's a variable. Well, but sometimes, teachers will be like, oh, pi is different with this. It's a variable.
Pi is a number. It's not a variable. It doesn't vary. Pi is what it is. It varies because people approximate it differently, but pi is a number. So in this case, my coefficient is pi to the 4th. So that is the number out front. Pi is not a variable. So that rule does not apply to my pi. So this is going to be 3 times that. So my u prime of x. Oh, actually, I just realized I wrote this one wrong. It should be of u. So u prime of x is going to equal 3 pi to the 4th u squared. You guys feel pretty good about this now? Hopefully. Shouldn't be x? Dang it, it should be x. I was seeing if you're paying attention. There you go. That's what I was doing.
I mean, that wasn't like a meaningful.
Yeah. I did that on purpose to see if you're paying attention. And you passed. Good job. All right. So, sum and theorem. So it's basically, you could add and subtract them, the 2 different ones together. So derivative of the whole thing is basically the derivative of each part. In each term. That's the word I'm looking for, terms. Okay. Find the derivative of this whole thing. So that means I'm going to do each term individually. So that would be f prime of x is, start there, that would give me, all right, and the next one would become
-12x + 2.
now this one right here. What is that? It's very good. It's a constant. It doesn't vary. There's no variable. So if there's no variable, if it's a constant, what is the slope of y equals -3? 0. So the derivative of a constant with no variable is always going to be 0. So do I need to write that? No, I don't. I don't need to write that there because I already have another constant here in my derivative. So I don't need to put +0. Now it says, what is f prime of 2? So that means I'm going to take 2 and plug it into my f prime. So 8 times 2 to the third minus 12 times 2 plus 2. So 8 times 8 is 64, minus 24 is 40 plus 2, 42? Maybe? Yes? Please check my work. Okay. C. Find the slope of the tangent line to the graph of f at the point 1, -5. Okay. So let's go ahead and start there. So I have 8x cubed. All right, so right there, and we're finding it at the point. What was the point? 1 what?
1 -5.
Okay. Now, just so you guys actually understand this and know where these things come from. So this coordinate right here is basically, it says this, that f of 1 should give me -5. My x and my y value from my original function. That's where I have to get those. And so you're going to have to, solve for those sometimes, and you have to get the y. You have to figure out where those are. Okay, so there's my x and my y. So now it asks for, find the equation of the tangent at that point. So first thing I have to do is f prime of 1. Now, help me out. What is f prime of 1 going to give me? It's the what? What is the derivative always trying to give me? It's the what? No. That would be normal. Okay. What is the derivative always giving me? What is the whole basis for everything that we've been doing all this time? Slope, right? Everything we've been doing is slope, the rate of change. So the slope, so this is saying that when x is 1, I want to know what the slope is when x is 1. So I plug that in. 8, 1 cubed minus 12 times 1 plus 2. So 8 minus 12 is negative 4 plus 2 is negative 2. So f prime of 1 so that means that the slope of the line when x is 1 is going to be negative 2. Yes? You guys okay so far? Now, we plug this into point slope. Which is going to be y minus y1 m quantity x minus x1. That's my x and y that I have up there. M is my slope. Y minus negative 5 equals negative 2 quantity x minus 1. Y plus 5 equals negative 2 x plus 2 minus 5 to both sides. So this is the equation of the tangent line. Next one is asking for, we're right here, right? Oh yes, normal line. So we know that normal should be what? Of the opposite reciprocal of what? The original what? Now function. Slope. So write that down for that. So the normal line is opposite reciprocal slope. So if I have this is my tangent line, my normal line is perpendicular to that. So that's a symbol for perpendicular. And if it is negative 2 is my slope, my opposite reciprocal is going to be a positive 1 over 2.
The opposite reciprocal of the slope of the tangent line.
Yes. And now we plug this into point slope again. So I'm going to have y minus negative 5 equals 1/2 quantity x minus 1. Y plus 5 equals 1/2 x minus 1/2. I'm going to add 10 over 2. I'm sorry, subtract. So I'm subtracting 10 over 2. Oh, wait. Yeah, 10 over 2. Why would I subtract 10 over 2? It's still 5, right? But as a fraction with my common denominator. So I'm subtracting that, and I get y equals 1/2 x minus 11 over 2.
reason for why it's called the normal line?
I bet there is. At this current moment in time, I don't think I've ever actually asked that. So.
Kind of weird, you know, like one's normal.
I know one's normal and the other one's tangent. So the one that we use all the time is tangent, but then we're like, oh, normal.
Is it because the concept of tangent is like not normal? So it's like the opposite is like normal?
I don't know. You can, but it's not necessary right now. Let's finish this.
I don't know. Yeah, wait, what makes it normal? What's the parameters for normal?
I don't know. Yeah. We'll look it up when we're done.
Okay.
Then normal means
All right, use technology. Find the graph of f, tangent line, normal line to the graph point on the same screen. I hate that my thing keeps resetting. Every day when I turn my computer on.
Would you have to do the like pairing thing?
No, I don't have to do the pairing thing, but I have to unpin all the Microsoft products again because they automatically pin themselves to my home screen. So I have to get rid of Microsoft Edge, Publisher, not Publisher, but OneNote and a couple others.
Just let it stay.
Huh? I have no idea. Anyway, all right. So right here, so we're gonna start with the equation. What was my equation anyway?
Which one?
The first one.
What is the first one? Do you want the
F.
Okay. F of x equals 2x.
2x.
Power of 4.
Wait. 2x raised to the fourth.
Minus 6x squared. Plus 2x minus 3.
Okay, so there's my function. Now, for those people that are actually following along on their calculator, because this skill right here is going to be important, to add another graph, I hit the tab button, and it's going to open that one up. And so this next one's going to be 8x to the third minus 12x plus 2. Oh wait, I don't want that one. I don't want the derivative. I want the normal, or the, what was it? Y equals, was it negative 2x minus 3?
Yeah. Yes.
That was the tangent, right? I don't know. Yeah, negative 2x minus 3. So there's my tangent, and then I need to put my normal line also. 1/2 x minus 11/2. Hit tab and control divide. Alright, so there we go. So the tangent line does cross my function more than once, but it's touching it at a singular point right here. So the slope at that singular point was the negative 2. and then the whole equation for this going through there, and then the normal line, the one here in black, is perpendicular to that, so it should cross this one right here at a 90-degree angle. Hmm?
It's like, I don't like the zoom. I don't know how it's worded.
Oh, you gotta play with it. Don't forget there is a mouse on there, so you can roll it
I know,
around.
that's what I'm trying to use, but it's like, and then I'm trying to unclick the little grabber hand.
Oh, then
zoom
hit
it back out.
hit escape.
Oh.
All right. Questions, concerns, complaints, conspiracy theories over this problem here. We just did a whole bunch of things, all of it together.
Can you pencil what a normal line comes from?
We will when we're done. I don't think we're done yet, are we?
I don't know. Yeah. How's that?
Hmm? Yeah. Oh, we gotta finish the notes today, so you guys could actually have all day tomorrow to work on the homework. All right, find the points of the graph where it has a horizontal tangent line. Horizontal tangent line, this is going to be super important. What is the slope of a horizontal tangent line? 0. There we go. So let's first find my derivative. So f prime of x is going to give me 12x squared minus 24x, and that thing goes away, right? That constant goes away. Now, this is going to be key to a lot of what we're doing here for the rest of the year. 0 is the magic number. Okay? It is magic. Anything times 0 is 0. So we could use the 0 product rule. So I want to find where something is 0, I use 0 product rule. So let's set this equal to 0. What else could I take out besides that x? Let's take out 12x, and I'm left with x minus 2. So here is where 0 product rule applies. Anything times 0 is 0. So this 12x, if this 12x is 0, no matter what the x minus 2 is, you get 0, right? So that would make this true. So each one of these in this is going to set it equal to 0 and make it true. So I break it up into 0 equals 12x, and 0 equals x minus 2. So here, x equals 0, and here, x equals a positive 2. Does that make sense? You're giving me a crazy look, Joseph.
I see it. I just gotta see it more, you know? Like, do more problems.
Okay. Okay, so what this is asking right here is where is the slope going to be positive and where is the slope going to be negative? So start by just creating a number line. And at 0, 2, so all I know is that the slope is going to be 0 right here, and it's 0 right here. So I am just going to check what my derivative is going to give me if it's going to be a positive slope or a negative slope. So if it's a positive slope, I know that it's going to be increasing up until this point right here, right? And if it's a negative slope, it would be decreasing to this point right here. So let's check -1. So my derivative was 12x squared. Actually, let's do this right here. 12x, x minus 2. No. So if I plug in -1, this is a negative. And I plug in -1 over here, that is going to also be a negative. And a negative times a negative gives me positive. So that means everything to the left over here is going to be positive. So let's check the number in between. Let's check number 1. If I check 1, this is going to be a positive. And over here, 1 minus 2 is a negative. So that means that everything from 0 to 2 is going to be negative. And let's check 3. So checking 3, that's going to be a positive. 3, that is also a positive. So that means that everything from 2 to the right is going to be . Now, using that information, we can kind of sketch what our graph should look like. I know that here, if it's positive to a negative, that means that it's going up to here. That's going to give me a 0, right? That's going to 0. And then from this point on, it goes down to here. And right here, it's going from negative to a positive, so it's increasing from that point on. And this is a sketch of the function, just using the derivatives. Make sense? Nonsense?
So to answer that, we just sketch it out.
Yeah, you could just sketch it. So this is what it was asking for. It's asking for the positive, negative, positive. So where is it positive? Where is it negative? So drawing the number line meets all that criteria. Yeah.
I get how to check it, but how did you get to do it?
How did I get the 0?
How did you
Which one? This one here?
everything is just like I get you set it to 0, but why did you take everything away?
This one or the one below?
Where did you get the first one?
This one right here?
Yeah.
This is the derivative of this. I don't think you actually were here the other day. So you missed out doing the derivatives for this. So we took the derivative of each one of the items and came up with that function right there. So, all right, there, yeah. Check the video on that. There is a rule for it. All right, so yeah, that's all you have to do from there, to add that. And that's all it asks for? Yes. And e to the x. The derivative of e to the x is e to the x. Is that easy? Yeah, it's e to the x.
It's kind of random, but you know.
Yeah. All right, so let's do each one of these individually. So it's going to give me f prime of x is going to give me 4e to the x plus 3x
Squared.
Yep. Make sense? Super easy right there. I'll do my best to make it more complicated later on. That's it. So, make sure you guys all like, share, and subscribe. We got what? 16 minutes of class left, and then I'm also going to give you guys tomorrow because I'm not going to be here. Make sure, yeah, check the merch store for new items.